So let's see the further remarks for the rules of surds. Beside the case that we need to consider complex number where we have negative number inside square roots. So next, please take notes where don't mix up the case of additions with the concept in multiplication in such that you have the idea that square root of a plus b, you can happen to break it to become square root of a plus square root of b. Where this is totally wrong. They are not equal to each other. They are not equal to each other. So one simple example you can happen to see is that, for example, let's say I happen to have square roots of 1 plus 4. So square root of 1 plus 4, you happen to notice that the answer is square root of 5. And square root of 5, if you try to evaluate using the calculator to have a quick answer, you find out that the answer is about 2.236 if up to 3 decimal places. Whereas, if you consider break it into square root of 1 plus square root of 4, this is equal to 1 plus 2, which is answer equals to 3. And you can see now, obviously, the result is not the same. So therefore, it doesn't make sense that they're equal to each other. The same idea also will go on if, let's say, we consider the case of minus. So, for example, if I consider the case of minus, let's see what will happen if I consider the case of minus. So I used a similar example just now. Let's say I have 4 minus 1. And the other one will be square root of 4 minus square root of 1. So what happened to the result when the time I have square root of 4 minus 1? And let's just check, are they happen to be equal to each other? So I have square roots of 3, where square root of 3 is equivalent to, or I should say approximate to 1.732. Whereas the other one, I have 2 minus 1, the answer is 1. So once again, obviously, the value is happen to be not the same. So we can see from this simple calculations here. Go on. Another thing that you need to be aware is that if let's say I happen to have the case of, and this one is important to be aware because if you encounter this thing here in chapter 2 equation, if I have square root of a plus square root of b, and I would like to square it, the answer will never ever same as square root of, it will never ever same as a plus b, a plus b. In other words here, where as if like what you do here from this result, you do square root of a square plus square root of b square and get a plus b. It is not happens to be correct. This is totally wrong. And again, we can have a simple trial that let's say I happen to plug in two values for calculations. Let's say I plug in again, let's say I make use of 4 and 1. And let's see what the result I have. So square root of 4 plus square root of 1, if I square it, this is happen to be equals to, so square root of 4 will be 2 plus 1 square. So as a result, I have 3 square, answer is 9. On the other hand, a plus b is very obvious. 4 plus 1 is 5. And once again, you can see that the result is not equal to each other. The similar situation happens for the case of minus. square root of a minus square root of b, it will never equals to a minus b as well. Again, you can try to do the calculation based on using the numbers and check using your calculator. The left and right hand side result won't be the same. And then what's supposed to be the result if, let's say, I happens to have square root of a plus b squared and square root of a minus b squared. So if you notice, we just have a quick look by using the rules m plus n squared equals to m squared plus n squared plus 2mn. So this one will give me the quick result for square root of a plus square root of b turn out to become a plus b plus 2 square root of ab in my answer. On the other hand, if let's say I have the other cases, I need to consider m minus n squared. So I have m squared plus n squared minus 2mn. And it will turn out the result. I'm supposed to have for square root of a minus square root of b squared. The answer is a plus b minus 2 square root of ab. And this expansion, again, is important to take notes for the next chapter, chapter 2, for its calculations to solve equations of surds.